Ever wondered about the math and science behind the Anulum Fortis project? Today, we delve deep into the project's fascinating concepts. Welcome to the intrigue of Anulum Fortis, a multidisciplinary project that sweeps across a broad spectrum of theoretical approaches. The project is a melting pot of concepts, each more intriguing than the last, pulling threads from diverse fields of study. It's a fascinating journey that begins with the forces that shape our universe, electromagnetism, and travels through the enigmatic world of quantum mechanics. But Anulum Fortis doesn't stop there. It ventures into the realm of consciousness, exploring its emergence and interaction with physical reality. It's a project that dares to ask the big questions, daring to probe into the philosophy of consciousness. So, are you ready to explore the mathematical formulas that underlie these concepts? Ready to dive into the mathematical language that describes our universe in the context of the Anulum Fortis project? Here we go. First, consider the concept of the electric universe. At its heart is the formula F equals Q times the sum of E and V cross B. This equation may look complex, but it's the key to understanding how the universe's structures could be shaped. Here, F represents the force acting on a charged particle. The Q is the charge of the particle itself. E symbolizes the electric field, while V is the velocity of the particle, and B the magnetic field. The electric field E and the cross product of the particle's velocity V and the magnetic field B get added, and this sum is multiplied by the charge Q to determine the force F. So, you see, this equation illustrates the potential influence of electric and magnetic fields on charged particles. This equation shows us the potential impact of electric and magnetic fields on charged particles, suggesting how the universe's structures might form. Next, let's examine the holographic principles of the universe. At the heart of these principles lies the Bekenstein-Hawking entropy formula, S equals A divided by 4G. Now let's decipher this. S stands for entropy, a measure of the disorder or randomness in a system. A represents the area of the event horizon of a black hole, while G is the gravitational constant, a fundamental quantity in physics. This equation suggests a fascinating concept. It implies that the entropy of a black hole, which we can think of as the amount of information it contains, is directly proportional to its surface area rather than its volume. This leads to the idea that information, and perhaps even reality itself, might be encoded on two-dimensional surfaces. This principle proposes a new way of understanding information storage and the fabric of reality. Now consider the fascinating area of emergent consciousness. This field is a bit of a conundrum as it dances on the edges of science and philosophy. It's a challenge to provide a simple mathematical formula for consciousness, given that it and its interaction with physical reality do not yet have a clear quantitative theory. Like trying to catch smoke with your hands, consciousness slips through the fingers of traditional scientific methods. Yet, the pursuit is not in vain. Theoretical and experimental research is ongoing, with scientists and philosophers alike delving into the mysteries of the mind. They are probing the depths of our understanding, seeking to quantify the unquantifiable, to define the indefinable. And while we may not yet have a definitive equation for consciousness, the journey of discovery is as important as the destination. While we don't have a definitive equation for consciousness, its study could revolutionize our understanding of the universe. Finally, ponder the concept of a pixelated reality. This concept is closely tied to Heisenberg's uncertainty principle, a cornerstone in the realm of quantum mechanics. This principle is represented by the equation delta x times delta p is greater than or equal to h bar over 2. Here, delta x and delta p represent the uncertainties in position and momentum respectively. H bar, on the other hand, is the reduced Planck constant, a fundamental parameter in quantum mechanics. This principle states that the more accurately you try to measure one of these properties, say, position, the less accurately you can know the other, in this case, momentum. This isn't due to any measurement error or technological limitations, but a fundamental aspect of quantum particles themselves. It's as if reality at the quantum level is pixelated or granular, not continuous as we might intuitively think. This principle hints at the intriguing possibility of a pixelated quantized reality. As we've seen, the Anulum Fortis project encompasses a range of intriguing concepts. The electrical universe presents us with the fundamental formula for the force acting on a charged particle in an electric and magnetic field, demonstrating how electromagnetic forces could shape structures in the cosmos. The holographic principles of the universe introduce us to the Bekenstein-Hawking entropy equation, suggesting how information, and perhaps reality itself, might be encoded on two-dimensional surfaces. In the realm of emergent consciousness, it's challenging to provide a simple mathematical formula, as consciousness and its interaction with physical reality don't yet have a clear quantitative theory. Research in this area remains primarily theoretical and experimental. The concept of pixelated reality, illustrated by Heisenberg's uncertainty principle, hints at the granular nature of reality at the quantum level. These mathematical formulas, while complex, provide a glimpse into the profound theories that underpin the Anulum Fortis project.